All right, we now are going to go ahead and we're going to use some of those properties that we talked about originally here. So the following is being able to write it in an expanded form, and it's easier to show you some examples than just to go on and talk about them. So this is what we would call simplified form. I want you to write it in an expanded form, so you need to pick one of our 6 properties that we've had. You see the division in there, so this is the log of x minus log of y. And that's all there is to it. So we're just applying our 6 rules here. So this is the division rule. All right. They can be made tougher. Let's just do another easier one first. So I'm taking the log of u to the 4th. If I want to expand that out, what happens, or basically what's going to happen here, is our exponent rule 1. So the 4 is going to come out front, and it would become 4 log u to the 4th. I was talking about some trickier ones. What happens if we have a square root in there? All right, so what happens if it's log of a square root of b? What I would recommend first is to get rid of the radical sign. So I'm going to rewrite it exactly as is, except I'm going to get rid of the square root sign. I'm going to use my exponential notation that we learned earlier in this unit. So square root is the same as b to the 1/2. Writing in an expanded form, we now have 2 terms. We have the a term multiplying the b term. So that means multiplication. So it would be log of a plus log of b to the 1/2. You still have to take care of this exponent here when you're writing in an expanded form. Some people are comfortable skipping straight to this step, which is fine. Actually, I encourage it when you're comfortable with it, but that would be your final answer there. So the 2 are equivalent expressions. All right. The 4th example, what happens if we change the base, not that it really matters, log base 9 of x squared y cubed all to the exponent 6. How do you deal with this one? The way you can deal with this one is to be able to apply your exponent laws. So our exponent laws. So what I want to do is I want to get it down. It's kind of looking like multiplication of one term multiplied by another, but I need to get rid of this outside exponent so it looks proper, so that I can apply that rule. So log base 9, and in the brackets, I'm going to distribute that 6 to both terms. So just using your exponent laws, I end up with x to the exponent 12, b to the exponent 18. Now I can apply it because I have one term inside the logarithm multiplying another term. Oh, I changed it to a b for some reason. It should be y to the 18th, multiplying by a term. So I end up with log base 9 of x to the exponent 12 plus, because there's multiplication in there, log base 9 y to the 18th. We have to take care of these exponents. And yes, you can jump to this final step. I do not need to see that other intermediate step if you are comfortable. And like I said, I do encourage it because it saves you a lot of time. There we go. So there are some examples of questions that I want you to be able to work with. I want you to be able to take something that's been simplified. I want you to be able to expand it, because there comes a time and place when that's necessary. Second portion of the lesson is going the opposite direction. It's taking something that's very complicated and simplifying it. So my example in this case, in terms of the simplification, let's do 3 log of x plus 2 log of y minus 5 log of z. All right, so the 3 terms here, I want to condense them, and I've got signs mixed in there. So these 2 terms have addition, so that means that their particular arguments are going to end up being multiplied together. However, this one is subtraction, so that means that there's going to be a division involved, and it's going to be dividing whatever is going to be on top. Okay, so that being said, let's do this one step at a time. I'm going to get rid of the underscore stuff for the moment. It's not deadly important. So here we go. First thing I want to do, let's get rid of coefficients. Okay, so that becomes log of x cubed plus log y squared minus log of z to the fifth. I know the first two terms, the argument is going to be multiplied together, and again that's because of this, the adding sign. So I'm going to have log, big brackets, x cubed multiplied by y squared. Because it's all one expression though, it's also being subtracted by that, so it's going to be using our division. So it's combining two properties together. It's combining our multiplication principle and our division, and also the exponent principles in there. So this is really an upper end question. They all have about the same level of difficulty in terms of the simplification. All I can really do is throw maybe some fractions in there or more terms. So for example, I could go 1/2 log base 2 of x minus 1/3 log base 2 w plus log base 2. All the bases are going to be the same. It's the only way those rules will work. Let's go with q. There we go. So the first thing you do is take care of your exponents. So you rewrite the exponents. Now, x to the 1/2 is the same as square root of x. Okay. Minus log base 2. Now, w to the 1/3 is just the cube root of w. So it's just using your rational exponent rules that we talked about previously in the first part of this unit. So you need to still bring that forward. And q, very similar to the first question. Now, it's a three-term logarithmic expression. So I'm going to have one final log here, base 2, and the root x is going to be over the cube root of w. Oops. Because it's subtraction. So this subtraction sign tells me take the argument from the first term, the root x, divided by the cube root of w, and then multiply it by the third term. So the q will appear on top. So it's log base 2 of root x cubed divided by the cube root of w. All right. That's kind of your upper end question. If you're comfortable with that, okay, it's going to take a little bit of practice. They all are about the same level of difficulty, whereas these examples, the expansion ones, they kind of grow in difficulty as you go through the homework. But these ones start out looking really ugly, but once you get onto them or get the hang of them, they go along pretty quick. So if you do have any questions, please get me over, help you with the explanation, so you can keep moving along.